Assalamualaikum warahmatullahi wabarakatuh. Good morning everyone. The Honorable Ma'am Agustina Ginting and all friends, thank you for joining our presentation today. It's great to see you all. Okay, let me introduce myself. I'm Mesyaro Azara and my partner is Imam Fatima. We are from Group 9 and we'll begin our presentation today about final project defense. The title is Design and Develop a Quality Monitoring System Indoor Air using ESP8266 based IoT or Internet of Things. The purpose of this presentation, we will discuss about how to design and develop a quality monitoring system indoor air using ESP8266 based IoT. We hope you guys grant all attention. Okay, first I will describe about what is background of our presentation today. Air is an important element for everyday life because air must have quality so that it doesn't have a negative impact on the body. Air is divided into two, namely outdoor air and indoor air. Other substances that are important to know the states of the air where we are, especially indoors because the pollution in the room is different from the air pollution outside the room. Indoor air pollution is one of the top 5 public health risks. The average person spends about 900 of their time indoors, so poor quality indoor air can pose a major risk to public health. The amount of activity and length of activity people do indoors the house requires the availability of good indoor air quality. In addition, the comfort aspect in the room must be considered because it can affect the activities and productivity of the people in it. Most people don't realize that some of their daily activities degrade indoor air quality. Most people think indoor air quality is better than outdoors, while studies show that indoor pollutant levels may be 2 to 5 times higher than outdoors. Low awareness of indoor air quality can increase the risk to occupation. This is exacerbated by the limited measuring instruments to monitor indoor air quality designed for residents. Most of the existing air quality measurements devices are designed for professionals, so that these devices are expensive and beyond the reach of the average user. The level of air pollution and comfort in the room. The easiest thing to determine whether a room is healthy or not is to know the humidity level of the room. Air humidity itself is different from air temperature, but people generally always consider it the same. The higher the temperature of an object, the hotter it is. To measure air temperature, you can use a thermometer, be it a wall thermometer or a laser thermometer. The level of weather vapor in the air is air humidity. Low air humidity can cause dryness of the air membranes, and if the air humidity in a room is too high, it can result in high growth of microorganisms. Abnormal humidity levels can become a respiratory problem and interfere with the health of humans in the room. Therefore, it is necessary to monitor the temperature and humidity of the air pressure in the room, which can be done at any time. This is what makes us want to design a tool that can monitor the temperature and humidity in the room based Internet of Things or IoT. It can be monitored from anywhere and anytime with Android. Okay, let's move to the next slide. What is the problem formulation about this presentation? A. How to make and design a monitoring tool based on indoor air quality monitoring, Internet of Things or IoT. And B. How is the indoor air quality monitoring process based Internet of Things or IoT? Then, how the problem limitations about this presentation? A. The control system in this project uses not MCU ESP8266, and B. This tool only can't be used in locations where there is no internet signal. Okay, about what is purpose of the project? A. Able to create and design an Internet Things or IoT based indoor air quality monitoring system, and B. Monitoring indoor air quality with a standard of 23 until 28 Celsius. Okay, for the next slide, we will describe about the IoT we use. The IoT we use is Blink apps. Blink is an application that can control the Internet of Things or IoT, which we can easily download for free for smartphone. This Blink can control IoT modules such as Arduino, Raspberry Pi, ESP8266, and Wemos D1 Mini. In this application, you can control the device remotely as long as the module is still connected to the internet network. The purpose of this application was created to be able to control hardware remotely, store data, display data from sensors, and other things that support system design that can monitor and control an IoT-based device. In the Blink application, there are three main features, namely 1. Blink apps. The Blink apps feature allow us to create interface project with various input and output components that support sending and receiving data and presenting data according to the select components. Data representation is in the form of visual number and graphs. There are four types of categories contained in Blink apps, namely controller used to send data or commands to hardware. A. Display, used to display data coming from hardware to smartphone. B. Notifications, used to send message and notifications. And C. Interface, display settings in the Blink applications can be in the form of menu or tabs. 2. Blink Server. Blink Server is a cloud-based backend service facility that is responsible for managing communication between smartphone applications and the hardware environment. The ability to handle dozens of features of hardware at the same time makes it even easier for many system developers. The Blink Server is also available in the form of a local server when used in an environment without internet. The local Blink Server is open source and can be implemented on hardware. 3. Blink Library. The Blink Library can be used to help with code development. The Blink library is available on many hardware platforms, making it easy for IoT developers with the hardware flexibility supported by the Blink environment. Okay, I'd like to move to the next slide. We will design tools and materials. Tools are one thing that is needed in making boxes, place of designs, and in making a series of designs which can be seen in table. Okay, our tools is solder, screwdriver, lighter, digital multimeter, cutting pliers, thin vacuum, laptop, and smartphone or handphone. And the components we use is ESP8266. For the details is ESP8266 12A not MCU and BME 680 sensors. BME 680 sensor is for humidity, temperature sensors, pressure and gases, and resource electricity is 3.7 volt lithium-ion battery, and buzzer speaker. For the details is SFM 27 active piezo buzzer speaker and connecting cable or jumper cable. Okay, for not MCU ESP8266, I'll describe about this microcontroller. Not MCU is an open source IoT platform. The term Not MCU by default actually refers to the firmware used rather than the development kit hardware. Not MCU can be analogous to the ESP8266 Arduino board. In the ESP8266 tutorial series, it discussed how to program the ESP8266, which is a bit troublesome because it requires several wiring techniques and an additional USB module to serial to download the program. But Not MCU has packaged ESP8266 into a compact board with various features such as a microcontroller with access to Wi-Fi capabilities as well as a USB to serial communication chip. BMA 680 sensors. The BMA 680 sensor is a digital 4-in-1 sensor with gas measurement, humidity, pressure, and temperature based on proven sensing principles. BMA 680 is an upgraded and better version than previous versions like BMP 180, BMP 280, BME 280. Gas sensor on BMA 680 can detect various compounds organic which easy efforts to monitor indoor air quality. The sensor has high linearity and high accuracy. The BMA 680 was developed especially for mobile and wearable applications where size and low power consumption are important requirements. To measure air quality, the gas sensor in the BMA 680 can detect a wide range of gases such as volatile organic compounds or VOCs. The BMA 680 is a metal oxide-based sensor that detects VOC through observations on the sensitive layer. Okay, you can see the picture of this presentation about indoor air quality. When IAQ index 0 to 50, air quality is good. When IAQ index 51 to 100, then the air quality is average, and the orange color is defined IAQ index 101 to 150 is air quality is little bad, and the red one when IAQ index 151 to 200 air quality is bad, and when IAQ index 201 to 300 the air quality is worse, and IAQ index 301 to 500 the air quality is very bad. The IAQ scale range from 0 or air clean up to 500 or air very polluted. During operations, the algorithm automatically calibrates and adapts itself to the typical environment in which the sensor is operated. The calibration process considers recent measurement history to ensure that IAQ 25 is air compatible, typical good, and IAQ 250 denotes typical polluted air. And the research electricity battery are devices that consist of one or more electrochemical cell with an external connection provided to power the such as electrical device, flashlight, cell phone, and car electricity. When battery supply electrical power, the positive terminal is cathode and the negative terminal is anode. The terminal marked negative is the source of electrons which will flow through the external electrical circuit to the positive terminal. When the battery is connected to an external electrical load, the reaction change the high energy tends to lower energy product. And we use buzzer speaker as our component according to Marpal. When buzzer is an electronic component that converts electrical signals into sound vibrations. The buzzer consists of a coil attached to a diaphragm. When the coil is electrified, it will become an electromagnet, so that the coil will be pulled in or out, which depends on the direction of the current and the polarity of the magnet. This leads me to the next point about system block diagram. Hardware design begins with making a system block diagram. Each block is designed with symbol to be interconnected between one block and another block. The block diagram for designing an indoor air quality monitoring system can be seen in this graphic. The working of the indoor air quality monitoring system begins when the NOT MCU ESP 8266 12E Wemos D1 Mini acts as an input and output data processor to process system work. The working stage of this indoor air quality monitoring system are when Node MCU gets power input from a 3.7-volt lithium-ion battery. Then all components connected to Node MCU will work according to a program that has been designed in such a way that it can see pressure, temperature, humidity, IAQ, CO, carbon dioxide, CO2 emissions, and organic vapor or VOC in the Blink applications. Okay guys, you can see the picture of this presentation about overall air quality monitoring system designs. The overall design of the indoor air quality monitoring system using IoT-based ESP8266 is seen in figure. That figure is the overall series of the design and build of an indoor air quality monitoring system using the IoT-based ESP8266 consisting of the Node MCU Wemos D1 Mini, 3.7-volt battery, switch, buzzer, and BME 680 sensor. All pins that are connected between components are arranged according to the program made on software Arduino IDE so that the tool can function properly. Okay, I'd like to move to another part of the presentation. In software designs, it begins with designing a flowchart, or what is commonly called a flowchart. Software design is divided into program designed on the Arduino IDE and designed on the Blink applications. The Arduino program function to give commands to each device to work as it should, while the design of the Blink application functions to monitor pressure, temperature, humidity, IAQ, CO2 emissions, and organic vapor or VOC. Software design begins by creating a flowchart, which can be seen in figure. Okay, look at the picture, guys. It's when it starts. If yes, is switch on? Yes or no? Yes, then initialization, and then the device connects to Wi-Fi. If no, it's switch on again. If yes, if switch on, then the initialization and the device connects to Wi-Fi, and then we must D1 Mini sense pressure, temperature, humidity, AAQ, emission CO2, and organic vapor or VOC on the Blink applications, and then display pressure, temperature, humidity, AAQ, CO2 emissions, and organic vapor or VOC on the Blink application. And then what is value IAQ? If it's more about 500 ppm, if it's then alarm live for 5 seconds, and if it's no, it's finished. And this is our 2D and 3D PCB, and this is the results when we use Blink applications for monitor indoor air quality. Okay, finally we get conclusions and suggestions. In conclusions, this indoor air quality monitoring will display a value pressure, temperature, humidity, AAQ, CO2 emissions, and organic vapors or VOC in the Blink applications. And for the suggestions, one, this air quality monitoring system is expected to be further developed by adding several features, such as warning sounds such as human voices speaking, and features to deal with if the AAQ value starts to increase. And two, the BME 680 sensors can be developed using other sensors that are more accurate in obtaining IAQ values in the room. Okay, thank you so much for your attentions. May all those we have shared be beneficial for you guys. And also thank you so much, ma'am, for joining our presentation today. And then wassalamualaikum warahmatullahi wabarakatuh. See you guys.